Good day. In today's laboratory, we'll be talking about switches and 7-segment displays. And our objectives for this laboratory is to introduce ourselves with current limiting resistors and pull-down resistors, switch debouncing, active low versus active high output, 7-segment displays, common anode and common cathode, and writing Arduino programs to read push-button switches and control 7-segment displays. Without further ado, let's proceed with our first circuit. So as you can see in the screen, we have the circuit 1. So our task for this circuit is to write a program for the Arduino Uno as described with the following functions. First, the count should be initialized to 0 and shown on the 7-segment display and the computer screen. When the user presses the button, the count should advance, and the new value should be displayed on the 7-segment display and the computer screen. The count should be mod 10, 0 to 9 and repeat. Use the display digit function, describe presentation for this lab, and use the read button function provided in this presentation for this lab to allow for switch debounce. So let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, the 7-segment display, the resistors, as well as the push button. So let's take a look at our code. Remember, this code sets up as a simple Arduino program to control a 7-segment display and the push button. So let's try to zoom in the code so we can see it clearly. So we have the pin configurations. This defines the pin used for the 7-segment display and the push button. We also have the digit patterns, which defines the binary patterns to display each digit 0 to 9 on the 7-segment display. Each binary patterns represent which segments of the display should be lit up to form the corresponding digit. We also have the variable initializations here. We have the counter, which to keep track of the current value displayed on the 7-segment display. The last button state to keep track of the previous state of the button. We also have the setup function. So this configures the Arduino pins as inputs or outputs. It sets the segment pins as outputs and the button pin as input with an internal pull-up resistor. It also initializes the serial communication for debugging purposes and display the initial value on the 7-segment display along the instructions. We also have the loop function. So this continuously checks the state of the push button. If the button is pressed, low state, and the previous state was not pressed, high state, it increments the counter, displays the new value on the 7-segment displays, and adds a debounce to avoid multiple increments on a single press. We also have the display digit function. This takes a number as inputs and display it on the 7-segment display by setting the appropriate segments according to the binary pattern for that digit. And lastly, we have the read button function. This reads the states of the push button and stores it in the button state variable. So let's try simulating the program. So as you can see, the moment that I click the push button, it shows number 1. If I click it again, it shows number 2, 3, 4, 5, 6, 7, 8, 9, and then it goes back to 0. Now let's proceed to our program 2, the switch controlled up or down counter. So our objective for this program are the following. Connect a toggle switch and a 7-segment display on the Arduino Uno board. Write a program to control an up-down counter using a toggle switch, that is, when the switch is on, the counter counts upward 0 to 9, otherwise it should count downward 9 to 0. Provide a 0.75-second delay for every count interval. Run the program and verify that it works properly. So let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the breadboard, the 7-segment display, the resistors, and in place of toggle switch, we have a slide switch because as aforementioned, we don't have a toggle switch in Tinkercad. So let's take a look at our program code. So we have the pin configurations. We have the segment pins as an array name. This array maps the Arduino pins to the 7-segment display. We also have the digit patterns as name for an array that holds the binary patterns to light up the appropriate segments for digits 0 to 9. And we also have the void setup, which initializes the pins to the 7-segment display as outputs, and the push button pin as an input with an internal pull-up resistor. We also have the void loop. This loop continuously reads the push button. Depending on whether the button is pressed, it either increments or decrements the counter and updates the 7-segment display to show the current value of the counter. And lastly, we have the display number. So this uses the digit pattern array to display the correct digit on the 7-segment display by setting the appropriate segments high or low. So let's try simulating the program to see if we're really accomplishing the objectives or the functionality that we need to accomplish. So let's try to switch the slide switch to count up. And as you can see, it starts counting from 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then it stops. Then let's try making the slide switch count down. And there you go. It counts from 9, 8, 7, 6, 5, 4, 3, 2, and 1. So as you can see, we've accomplished the task wonderfully. And the function is working properly as we want. So let's proceed to our program 3, presettable up-down counter. So our objective for this program are the following. Connect a toggle switch, 3-switch dip switch, and a 7-segment display on the Arduino Uno board. Write a program to ask the user to enter a predefined number to start the count from and a toggle switch input to determine whether to count up or down. The program can be switched from up or down interactively by switching the toggle switch. Provide a 0.75-second delay per count transition, and run the program and verify that it works properly. So let's proceed to our Tinkercad. So as you can see, we've already placed the components. We have the Arduino Uno board, the 7-segment display, the resistors, the dip switch. Unfortunately, we only have a 4-switch dip switch. We don't have a 3. And we also have a slide switch in place of toggle switch because we don't have a toggle switch as well in Tinkercad. And the wires connecting all of them. So let's take a look at our program code. So aforementioned, this code sets up an Arduino to control a 7-segment display using a dip switch as an input to increment or decrement the displayed number using a toggle switch, but in our case, we'll be using slide switch because we don't have a toggle switch in Tinkercad. So we have the global variables. We have the switch pin, which is the pin connected to a switch. We have the dip array storing the pins connected to the dip switch, the 10, 11, 12. We have the display array storing the pins connected to the 7-segment displays, and the display count up, which is the Boolean variable to determine the counting direction. We have the count, a variable to store the current count. We have the simulation started, which is a Boolean variable to track if the simulation has started. And the dip entered, which is a Boolean variable to track if a number has been entered via dip switches. And we have the current state, enum variable, representing the current state of the simulation. And again, we have the setup function, which configures pin modes for the switch, dip switches, and 7-segment display, which includes a delay of 2 seconds or 2000 milliseconds. We also have the loop function, which implements a state machine using a switch case construct based on current state. We have the wait for start, which immediately transitions to the enter number state. which reads the number from the diff switches using the read_diff function, displays the number on the 7-segment display, and transitions to simulation running state. So this determines the counting direction based on the switch. It increments or decrements the count based on the counting direction. So this is based on the slide switch. And drops the count around if it exceeds the limits 0 to 7. Displays the updated count on the 7-segment display, and delays of 750 milliseconds is placed. We also have the read_diff function, which reads the value from the diff switches and returns it as an integer. We have the display digit function, which displays a digit on the 7-segment display based on the provided digit value. This uses a Boolean array digit patterns to represent the segment of each digit. It ensures the input digit is within valid range of 0 to 7. It sets the corresponding segments of the display based on the digit pattern. That is all for our program code. Now let's try simulating to see if we're really satisfying the conditions or the functionality of program 3, the presentable up-down counter. Start simulation. So let's try in. We have already placed the 3 binary value. And as you can see, the slide switch is switched to the left, so it is counting down. If I switch this to the right, it should count up. And there you go. It counts from 5, 6, 7. And then I'll try to turn it to the left to count down again. You have the 7, 5, 6, 5, 4, 3, 2, and 1. So as you can see, we satisfy the condition. In the beginning, we have the 2 and the 3 binary, or in binary we have 1, 2, so it sums up to 3. That's why when the simulation starts, we have displayed 3 on the 7-segment display. That is all for our program 3, presentable up-down counter.
For program 4, traffic light circuit with 7-segment down counter. Connect 3 LEDs, green, yellow, and red, and 3 220 ohms resistors to the digital output pins of your choice. Write a program to simulate a traffic light where the green LED is on for 9 seconds, yellow if on for 1 second, and red is on for 8 seconds. Provide synchronized timing to the down counter. The traffic light should operate forever. Pin configuration. The segment pins array contains the pin numbers corresponding to the segments of the 7-segment display. Each element in the array represents a segment A, B, C, D, E, F, G in that order. For example, segment pins 0 corresponds to segment A, segment pins 1 corresponds to segment B, and so on. Number definitions. The digit patterns array holds the binary patterns for each digit 0 to 9 to be displayed on the 7-segment display. Each element in the array represents the state of the individual segments A to G for the corresponding digit. For instance, B11000000 represents the pattern for displaying the digit 0, where segments A and B are turned on binary 1 and the rest are off binary 0. Setup function. In the setup function, the code initializes the segment pins 2 to 11 as output pins using pin mode. These pins will be used to control the individual segments of the 7-segment display. Loop function. The loop function is where the main logic resides. It cycles through 3 different colors, green, yellow, and red, by turning on and off specific segments to display the numbers. The display number function is called to display each digit, displaying numbers. The display number int number function takes an integer argument 0 to 9, representing the desired digit. It retrieves the corresponding binary pattern from the digit patterns array. For each segment A to G, it sets the output state based on the pattern. Color cycling. The code cycles through the colors green, yellow, and red by turning on the respective LED connected to pins 9, 10, and 11 during each color phase. Within each color phase, it displays the digits from 0 to 9 sequentially. Let's see the simulation in both Tinkercad and Actual. Program 5. Design your own switch and 7-segment application. Construct the test circuit on your Arduino Uno board. Pin configuration. You've defined the segment pins array, which contains the pin numbers corresponding to the segments of the 7-segment display A, B, C, D, E, F, G. These pins are set as outputs in the setup function. Digit pattern. The digit patterns array holds 2 patterns, both set to B10000000 for displaying the digit 0. Each bit in the pattern corresponds to a segment, where 1 represents an active segment turned on and 0 represents an inactive segment turned off. Button input. You're using a button connected to pin 9 with a pull-up resistor to trigger the display of the digit. When the button is pressed transition from high to low, the display number 0 function is called. Display logic. The display number int number function sets the segments of the 7-segment display to display the digit based on the provided pattern. It alternates between turning on and off the segments to create a visual effect. The delay of 100 milliseconds between segment changes controls the display speed. Marquee effect. The function first displays the digit from left to right segments A to F, and then from right to left. This creates a marquee-like animation effect. Let's see the simulation in both Tinkercad and Actual. Program 6 7-segment display marquee effect. Construct the test circuit on your Arduino Uno board, which comprises of the following components. 2 pieces, LDR light-dependent resistor, 2 pieces of 7-segment display or dual display, whichever is available. Create a program that will display a marquee effect of 2 messages. If LDR1 was enabled, it should display the message hello from left to right direction. Otherwise, display the message bye from right to left direction. Segment mapping. The segment map array defines the binary patterns for each digit 0 to 9 on the 7-segment display. Each element in the array represents the state of the individual segments A to G for the corresponding digit. For example, 0B00111111 represents the pattern for displaying the digit 0, where segments A and B are turned on binary 1 and the rest are off binary 0. Custom segment mappings. For letters, you've extended the mapping to include letters H, E, L, O, B, and Y using the letter map array. For instance, 0B01110110 corresponds to the letter H, where segments C, D, E, and G are turned on. Pin configuration. The segment pins array contains the pin numbers corresponding to the segments of the 7-segment display A to G. The digit pins array holds the pin numbers for the common cathode digits of the display. Photoresistor inputs. You're reading analog values from two photoresistors, photoresistor pin hello and photoresistor pin bye. These photoresistors detect light levels. Thresholds and message flags. You've set thresholds threshold hello and threshold bye to determine whether to display hello or bye. If the light level is below the threshold for hello, show message hello is set to true. If the light level is below the threshold for bye, show message bye is set to true. Display logic. The display message function handles displaying the messages. It cycles through the message characters, creating a marquee effect. The display marquee function displays the characters at the specified position. The display character function sets the segments based on the character, digit or letter. Multiplexing and refresh rate. You're using a short delay 2 milliseconds to allow multiplexing between digits, creating a fast refresh rate. Let's see the simulation in both Tinkercad and Actual.
And that's all for our laboratory exercise number 4, interfacing 7-segment display. Thank you for watching.